Good morning, good afternoon, and good evening. This is Mrs. Radel back with another Algebra 2 video. Today we will be learning about compound interest. In the last few lessons, we've been talking about exponential growth. And a very common example of exponential growth is compound interest. Some of you may have heard of compound interest, some of you maybe have not. So let's start with $1 in the bank. If the interest rate is 20%, we will end up with $1.20. Now, when the bank wants to give us more interest, they don't base it off that dollar, they base it off of the $1.20. So then when we have 20% interest on $1.20, we're going to get $1.44. And they would keep doing that. So 20% of $1.44 would give us about $1.73. And so the interest compounds. The more money you earn in the interest, the more interest you'll be able to earn. So let's look at the compound interest formula. It says A equals P times 1 plus R divided by N raised to the N times T. And so A is our output. It is the amount of money in the bank, which includes the initial that we put into the bank and all of the interest. The P represents the initial amount that we transferred into the bank account. And sometimes they call it, most of the time, they call it the principal. The R represents our rate, just like before. We have to change the percent to the decimal. And the N talks about the number of cycles per year, which we'll go into a little bit more detail about. And the T represents the time in years. So what will make this very clear is to do a few examples. So it says, Seth's parents gave him $5,000 to invest for his 16th birthday. He is considering two investment options. Option A will pay him 4.5% interest compounded monthly, and option B will pay him 4.6% compounded quarterly. Write a function of option A and option B that calculates the value of each account after, we'll say after T years. After T years. Okay, so let's start to fill out our equation. A is going to be the output, so that's our function's name. The principal is how much he is investing in the first place. So he is investing $5,000. I'm just copying down the formula and filling in what I know. So 1 plus, and the rate is 4.5. And don't forget, when we're changing percent to decimal, we need to divide by 100. And so the rate is 0.045. And we're going to divide by the number of cycles in 1 year. So if it's being compounded monthly, how many months are in a year? 12. So let's put 12 as our denominator. And now we know that N is 12, so we're going to put the 12 up here. And we're going to use for T years. Okay, so that's our function for option A. And now let's make our function for option B. So A equals the initial investment, or the principal, times 1 plus 4.6 as a decimal is 0.046. And now it says that it will be compounded quarterly. So if it's being compounded quarterly, that means it's going to have 4 cycles every year. 4 cycles every year, 1 for every season. Close the parentheses, and then we're going to put the 4 up here in the n place, and we're going to leave the t to mean number of years. So where t equals the number of years. Okay, so now it says Seth plans to use the money after he graduates from college in 6 years. Determine the amount of money in each account at this time. So now we know the value for t. T equals 6. So wherever we see a t in our equation, we're just going to substitute in a 6. So let's copy down our equation. A equals 5,000 times 1 plus 0.045 divided by 12 raised to 12 times 6. And we'll get that our amount in that account is going to be about $6,546 and let's say 52 cents. So if he puts $5,000 into the bank, doesn't put any additional money in there, after 6 years, he will have $6,546.52 in this account. And we can do the exact same thing for option B. Let's do A equals 5,000 times 1 plus 0.046 divided by 4 raised to the 4, and now t equals 6. And that is going to be an amount of $6,000, 578 and 87 cents. And so now we've answered the question, and if we want to find the amount of interest that he has earned from these two accounts, we can just subtract the amount by the initial investment. So we could, this isn't what the question's asking us to do, but we could find the interest gained. Interest is equal to this amount A minus the original investment. Okay. So it's going to be equal to about $1,500. And we could do the same thing over here if we wanted to find the interest. It would be equal to $6,578.87 minus the initial investment of $5,000. And so the interest earned is actually slightly more for option B than option A. It's about, let's say, $32 more if you go with option B, because even though it's compounding less frequently, there was a higher interest rate. All right, Algebra 2, you have all the information you need to answer those questions on eDoctrina. So go ahead, thank you for watching, and I'll see you in the next video. Goodbye.